Welcome back to the shop and to the channel. Well, I want to try to get back to getting this universal head operational on the K&T horizontal mill. Really the only thing I have left to do is to get a drive gear mounted in the spindle. Now, unfortunately, I can't mount the drive gear directly to the spindle using the 4 mounting holes because the gear just isn't big enough. There's no way to actually mount it. So I'm going to have to come up with an arbor. Well, it just so happened that when I bought the machine, it came with this blank tool holder. And I think this might just be exactly what I need to use. I think if I machine this thing down to accept this gear, I think I'm, halfway home there and getting this drive gear mounted and getting this universal head, operational so I can use it. But since I don't have any drawings on the actual drive gear, I need to take some measurements and figure out just how much space I have and how this thing needs to end up mounting on the spindle. If we look up here inside the drive bracket, you can see the driven gear in where it's situated up inside there. And I know that the back of this drive bracket sits flush with the face of the column. So if I can get sort of an offset of how far that gear is away from it, it'll give me some information to work off of. I also need to take into account just how far the spindle sticks away from the column, because again the gear is going to be offset by at least that amount. I'll try to use this depth micrometer, see if I can't get just a little bit more accurate of a dimension. This is actually quite challenging because I really need to get pretty close, probably within 10 thousandths, and using a scale just I don't think is going to be accurate enough. Well, unfortunately, I didn't think ahead when I had this thing apart. I should have measured that gear a little more accurately, this driven gear, because how thick it is and where it's situated inside this housing will make a difference. I might end up having to take this thing back apart at least a little bit in order to get some more accurate measurements. I think I will go ahead and take this apart off camera. I won't bore you with that. And at least that'll give me an opportunity to measure this gear properly and take some more accurate offset measurements. Well, the next problem I need to solve here is how to make this arbor for the gear concentric with the spindle. I thought about chucking this up in the lathe and then maybe dialing it in, but then again, there's no guarantee that the circumference of this blank is concentric with the back of the tool holder. Concentricity is going to be as important as ever. And then I got the idea, well, what if I just used a lathe tool to cut this on the horizontal mill itself? Turn the horizontal mill into a lathe, and that way I assure concentricity of whatever I machine here with the spindle. Well, I have this BXA tool holder that I can use with my lathe tooling. If I can mount this to the table, I can drop a tool on it and just move the table as if it was the cross slide and carriage of a lathe. Well, the next Problem then is, how do I mount this tool post to the table? I can't use the T-nut that I have for it, but I have another idea. I think if I could make a T-nut that would fit for this post, then that might work. Unfortunately, the slot's actually too narrow for this. There really wouldn't be much thread left in the T-nut. Well, then I was thinking, well, what if I just took a piece of 1/4-inch plate and drilled a hole and tapped it in the center and mounted the tool post directly to it. Well, then I could just then drill some holes and use T-nuts and some studs to mount the plate to the table, and Bob's your uncle. Well, maybe not quite that easy. This stud here for the tool post is cut with metric threads, and I have 0 metric dies and I have 0 metric taps. So I'm going to have to remake this in Imperial. And I just happen to have this piece of, I think this is stainless steel rod, at least it looks like it. That is the right inner bore that'll go down inside this tool post. And so I'll just cut some Imperial threads on it and tap a Imperial thread in the base plate. But before I get too far ahead of myself in drilling and tapping holes, I think what I want to do is clean up that base plate. I can't leave it with all that mill scale on it, and quite frankly, the easiest way to clean this up is going to be on the Bridgeport with a fly cutter. Well, with the two large surfaces nice and clean and flat, I might as well go ahead and take care of these other edges. Well, off camera, I went ahead and put some blue dicum down the center of this and set some layout lines for where I want to drill the clearance holes for the studs for the T-nuts, and then the center hole for the tool post. These aren't, anything really precision. As long as they're in the same line, it's fine. So I'll just use a wiggler here to locate them and drill them through. Well, I was going to tap this hole at 5/8 24, but I didn't have the tap drill size for that thread pitch. I have the taps, but I don't have the clearance drill, and so I picked 5/8 16, which won't be as strong as a 5/8 24, but I think for the limited use that this is going to see, I think I'll be okay. Well, I can move on to making the stud here. I've got it cut to length that I need. I'll face this off, and I'm going to put a center in it. I am going to single point thread the stud, and that's because at the time that I recorded this, I did not have a 5/8 16 die. I have since acquired one, but a little practice single point threading never hurts. Well, with the center drilled, I'll bring in the tailstock for some support. There's quite a bit of stick out here, so definitely going to need this to eliminate any issues with tool pressure. I just need to turn down the diameter of the end of this stud here to the appropriate size so I can start threading it for 5/8 16. Well, I'm sure most of you have seen this stuff a million times before, single point threading. There's channels out there that do a much better job of explaining and showing it than I ever could. But just to summarize, I'll take a scratch pass here in order to validate I've got the thread pitch correctly, and then we'll start cutting these threads to depth. I really like using these thread pitch micrometers. I think they're pretty easy to use. I've only tried using the 3-wire technique like once, and that was a long time ago, and I hated it. And ever since I found these thread pitch micrometers, this has been my sort of go-to for, checking threads when I don't have like a nut handy to check some clearances. I'll do that here in a bit, but I just find using these micrometers is so much easier than the alternative. Well, I just broke the tip of the thread insert, which I deserve because what I should have done from the beginning before I started cutting these threads was to cut a thread relief, and I didn't. So now I'm just going to take my cutoff tool and just cut a little bit of thread relief here in the end of this thread so I can avoid breaking any more inserts. Well, we'll do a quick test fit here on that plate. Yeah, and I think that's going to work just fine. I'll go ahead and thread the other end off camera. Well, I could run to the hardware store and get a 5/8/16 nut, but what fun is that? I have some hex stock here, and we'll go ahead and make a 5/8/16 nut to hold the tool post down onto that stud. Well, the first thing I need to do here is I want to go ahead and face the end off and then put a nice healthy chamfer on the end. Off camera, I took it over to the bandsaw and cut it off to a reasonable length, and I want to go ahead and chuck it up so I can finish machining it. I'll use a parallel here against the face of the chuck to try to get this thing as square to the chuck as possible. Well, with that faced off, now I can drill this and tap it for 5/8/16. I am going to go ahead and flip this back over in the chuck just so I can take that chamfer tool and clean up the ends of the threads here in the top of the nut. Well, I've got a piece of 4140 chucked up in the lathe here. I need to make a washer to go underneath that nut. Well, I need to turn down the diameter of this here just a little bit so that it fits correctly on the top of that tool post. And then I'll drill it for the clearance hole for the 5/8 stud. Before I cut this off, I do want to chamfer this inside hole just to give it a nicer look. I again don't have a specific dimension in mind here for this, so I'm going to make it about 125 thousandths thick. I do find that for this lathe, I get the best results by running it in back gear super slow. And then what I do is I set the feed rate on the compound to the finest feed on the power feed. And I engage the compound power feed and let it go. And on this 4140, you can see it is cutting a nice thin ribbon of steel. Yeah, it takes a little bit longer, but I am consistently getting good results, especially with these harder alloys. And I'm not breaking inserts nearly as often as I had been. Of course, coupled with adequate lubrication. And that went really well. So I will go ahead and deburr this thing and chamfer the opposite side off camera. Well, that's it for all of the machining. So I can now mount the base plate here to the table with a couple of T-nuts and some studs. Well, the tool post stud, the threads on it are longer than the plate, so it just needs to fit down inside that T-slot. Well, with all that tightened down, I can drop the quick change tool post over the stud and then drop on the washer and the nut. And with the tool mounted in the post, we are ready to go. I'm ready to go ahead and mount this blank, and I can start machining this arbor for the drive gear. But unfortunately, that is going to have to wait until another video. But if you like this video, I'd appreciate it if you get a thumbs up. If you're not a subscriber, consider hitting that subscribe button, and you'll get notified if you hit that bell icon when I publish another video. I really appreciate you hanging out with me while I convert my horizontal mill into a lathe. Thanks for watching, and we'll see you on the next one.